So yesterday we did 2 with solving with the graphing calculator. So we're going to do at least 2 more with solving with the graphing calculator, and then I'm going to give you the rest of the time to work on the assignment. Now, whenever we type these into the graphing calculator, the first thing we need to do is write it as an augmented matrix. So going across the top, our first row would be next one would be, and the last one would be, and our dimensions would be a 3 by 4. Any questions on how we made the augmented matrix? Now the next thing we need to do is we need to type this in to the graphing calculator. So we can pull the graphing calculator up. Clear. So the first thing we need to do is input the matrix. So we'll do second matrix, and we'll go over to edit, and we'll hit enter. We'll plug this into matrix A. Now matrix A is a 3 by 4, and we type in the first row, which is 2, 3, -1. Nope. So I was looking at the wrong one. Yeah, it should be 1, 2, -3, -2. And then 1, -1, 1, -1. And lastly, 3, 4, -4, 4. Are we all able to get it typed in? Okay, that's fine. Once you get it typed in, second quit, second mode. You're all good for the next step. Yes. Second quit. Now the next thing we need to pull up is RREF. So to get that, we'll go second matrix. This time we'll go over to math and scroll all the way down to RREF and hit enter. So we have this here. Now we need to input the matrix or tell it which matrix we want to apply this to. And to do that, we'll do second matrix and select the matrix that we wanted, which is A. Hit enter one more time, and we get this here. Any questions on how we got to this point here? Now the solution for this 3-variable system of equation is the last column, or 0, 5, 4, where x is the first number, y is the second, and z is the third. So our answer is 0, 5, 4. And that's it. Questions on this here? We're ready for the next one. Now this one here, the variables are all in the correct order, so we can go on and write the augmented matrix first. So we would have 1 for x, 3 for y, -1 for z, and 1. Our next one would be -2, -6, 1, -3, and lastly we have 3, 5, -2, 4. And this is still a 3 by 4. on and type it in. So to type this in, we would go second matrix over to edit, and we'll hit enter to plug it into matrix A. Still a 3 by 4, but this time we have 3, 2, -5, -10. Oh, I'm looking at the wrong one again, because it's supposed to be 1, 3, -1, 1, -2, -6, 1, -3, 3, 5, -2, 4. We got it all typed in. Then from here we go second quit, yes? Now, we feel comfortable finding R, REF, and then doing matrix A, yes? Well, I'll show you this. I already have it typed in. So I'm going to go up and highlight it, hit enter, enter. It'll give it to us because, again, we changed matrix A, so it applied it to the new matrix. So 201 is our solution. Questions on any of this here? Are we ready for the last one? Nice. Now we're good with the first row being 3, 2, -5, and -10, yes? What would the numbers going across the second row be? 6, 0, -1, 8. Because there is no y, we have to put in a 0 for it. Now since the last one does not have an x, we put in a 0 for it, -1 for y, 3, -2. And this is still a 3 by 4. Second matrix A, 3 by 4, 3, 2, -5, -10, 6, 0, -1, 8, 0, -1, 3, -2. Second quit. Then we get our R, REF, and we get this here, yes? What is our x value written as a fraction? Well, let's have the calculator do this for us. If we hit math, the first one is FRAC. If we hit enter, since we didn't put a number in front of it or anything in front of it, it's saying the previous answer, A and S. We're telling it to take the previous answer and turn any decimal into a fraction. So if you do get decimals, you can do this and it'll convert it to fractions. So our answer is -2/3, -34, -12. Math, enter, enter. Okay. Now, there's two other matrices I want to show you just plugged in. 3, 4, 1, 1, 1, 2, 5, 5, 5, 3, 4, 1, -3, -6. Second quit. Enter, enter. Now, if we look at the last row, we have all zeros and a 1. What that's really telling us is that this is a no solution. Because what that last row is, because we do have other numbers, 1, 2, 3, 1. This is saying that x, y, and z are all 0, and that 0 equals 1, which does not work, so this is a no solution. It doesn't matter what the other numbers are because we have this on one of the rows. It does not work. Does this make sense? Now, if we ended up getting a matrix, it could have 3. It could have, as a 2 by 3 would have 3 of them, or 3 by 4 has 4 zeros at the bottom. It's an infinitely many. Many solutions. We kind of see the difference between those two. Okay. But other than that, you have the rest of the class time to work on the assignment.